Good morning, girls. How are you? I hope you are all doing fine. Okay. Before we start in our new lesson, we just have to revise the previous lesson, the questions that I left for you. I just need to make sure that you understand it well. You remember in the previous lesson, it was called proving figures are congruent using rigid motion. In this questions or in this lesson, you're required to find a sequence of transformation that can change one object to the other. And this sequence of transformation is rigid so that it can keep the size and shape equal. So the two figures will be congruent. And the first question that I left for you was in page 898. And it was this question. Use the definition of congruence to decide whether the two figures are congruent or no and explain your answers. And in this question, I told you that you have to tell him if the two figures are the same or not and how can they map into each other. There is only one note that I didn't say. When you have two figures, how can you know which one of them is the original and which one of them is the image? The original one, girls, will always be the one in black. The one in gray, the faded one, is the image. So here A, B, C, D is my original figure. This is my original. So how can I change this into this? Remember the rigid transformation we are talking about is reflection, rotation, and translation. What do you think? The two figures appears to be the same or not? Yes. So the first sentence I will write, the two figures appears to be the same. And then I will tell him how can I change this into this? Can you see that the two figures appears to be in front of each other exactly? As if they are seeing each other in the mirror. Yani A is the same as W. D is the same as Z. B is the same as X. C is the same as Y. So how can you see two figures in the mirror if you do what? If you do a reflection. So it's very obvious that a reflection across X axis happened here, right? So this is what we are going to write. The two figures appears to be the same. I can map using, I can map A, B, C, D into W, X, Y, Z using reflection across X axis. And then I will write the coordinate notation. Of course, to reflect across X axis, I should put a negative for Y. So this is what we wrote. X and Y is going to be X and negative Y. Now let's see the second question. Again, they appear to be in front of each other, but if you do actually reflection, of course, here GKLM is the original one because it is the black one. If I started here, if I do a reflection across y-axis, L will not land here. Actually, L will be there, right? So what happened? What made L move from this place to here? The same thing is happening for this point, for example, J. J will be in here. If it's reflected, it will be in here, but it moved to be there. And the same thing for K. K should be here, but then it moved to here. Moved means translation. So actually what is happening here? A reflection is happening because I reflected across Y, and then translation, right? So I will write the two figures appears to be the same. I can map them using reflection, then translation. And then I will write the coordinate notation. Since you are reflecting across y-axis, so I should put a negative for x. So this is what I'm going to have. The first coordinate notation, x and y is going to be negative x and y. What about the translation? To count the points of translation, let's count the squares. After reflection, L should be in here, for example. I'm going to trace any point I want. I traced L. You can trace any point. L is going to land in here. Then it moved 3 squares to be in here, right? From here to here, it's a 3 squares. Now 3 squares is how many points? Let's count the number of points. Each square is 2, because this is 0, 2, 4, 6, 8. So each square is 2 points. And since I moved 3 squares, so 3 multiplied 2 is 6. So I moved to the left 6 points. Since it's 2, did I move up or down? I didn't. I only moved left. So since I moved left, it's going to be x minus 6. So x and y, it's going to be x minus 6 minus, because it's left, 6 because it's 6 points, 3 squares with 2 points, and y as it is because I didn't move up or down. Okay, in page 899 as well, I left for you 2 questions in here, page question 5 and 6. Let's think about question 5. How can I map these 2 figures to be each other? First of all, this is the original one, and then this. Again, they appear to be in front of each other. They appear to be in front of each other. But then something else happened. Yani if I did a reflection, because they are very opposite, K girls is the same as X, right? If I do a reflection, K will be here. If we did a reflection across X, because they are in front of each other, K will be in here. But actually the image is there. So what happened? K moved 1 square down and 2 squares left, right? If you trace another point, point L, for example, is the same as Y. If you do a reflection for L, L will be here, exactly. What happened to L? It moved 1 square down again and 2 squares left. So what I'm doing here, I am doing reflection followed by translation. Reflection across what? Across x-axis. So if we write the coordinate notation, x and y is going to be x and negative y. Always put the negative for the other side since it's across x, so put a negative for y. What about the translation? 1 square down, so it's y minus. And 1 square is how many points? 2 points, so y minus 2. What about left? Left, so x minus. How many squares left? We moved 2 squares left. 2 multiply 2 is a 4, so x minus 4. The last question was question 6. What do you think about question 6? Again, let's trace a point and see. These 2 figures appear to be in front of each other. As if we are doing maybe double reflection, we will see. Maybe I'm wrong. Let's trace a point. Point A, for example. Point A is the same as point Q. No, it's the same as point P. Sorry. A is the same as point P. If we do a reflection across y-axis to make it in here, then if we did a reflection again across x, it will be in here. So is it the double reflection? No, it's not. So it's a what? A, if it's reflected across y, it will be here. What made her move down? Move. Let's take another point. Point A, if we do a reflection across y, it will move, it should move 1, 2, 3, 4, 5 squares down. Let's trace another point. Let's take, for example, point B. Point B is the same as Q. Let's do reflection across y. Across y, it will be there. And then it will move down. How many squares? Let's count the squares. 1, 2, 3, 4, again 5 squares. So we found it. So actually what's happening here? It's reflection across y-axis because they should land in the other side, followed by translation. Translation down, left, right, or up, only down. There is nothing left or right, only down. So it's going to be y minus. Since 1 square is 2 points, so 5 squared multiply 2, so it's a 10, so it should be y minus 10. So this is what we are going to write. First of all, we did a reflection across y, so x and y is going to be negative x and y. We add a negative for x. Then we did a translation down 10 units. Why 10 units? Because it's 5 squares and 1 square is for 2. Because here it's a 0, 2, 4. So each square is 2. So 5 multiplied 2 is a 10. So y minus 10. Well, minus because you moved down. Okay? Okay, very good. We finished this lesson. We are going to start in our new lesson now, lesson 18.3. Okay, the new lesson is very, 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 very easy. I think you will find it easy. and actually it is like a gateway for us to begin moving to module 19. From now on, you don't need rulers, you don't need, you need rulers maybe, but you don't need a lot of protractors, compasses, nothing. All of our work will be numbers, degrees, and these things. Okay, corresponding parts of congruent figures are congruent. This is the most important sentence, and actually it is the headline of our lesson. Corresponding. First of all, what is corresponding means? What is a corresponding? Corresponding means the same. Yani two things in front of each other. These are corresponding. Yani for example, when I tell you that, when I write, for example, something like this, like for example, let's write a text that a x y, or for example a plus x plus y is equal to 2 plus 3 plus 4. And I tell you, find the corresponding numbers. Corresponding means each part in here, what is the facing number of it in the other side? This is corresponding. Corresponding means the two things in front of each other. So it's very obvious here that A is corresponding to 2. It is in the same place, but in the other side. X is corresponding to 3. Y is corresponding to 4. So this is corresponding. So we can write here that A is equal to 2. Sorry, A is equal to 2, X is equal to 3, and Y is equal to 4. So this is a corresponding. This is corresponding. Corresponding yani things in front of each other, facing each other. So corresponding parts of congruent figures are congruent. Many things in front of each other in two congruent figures are congruent. We will see what is this as we go. Okay, first of all, fold a sheet of paper in half, use a strategy to draw a triangle on the folded sheet, whatever, to produce two congruent triangles. This is what I'm caring for, beginning from here. I have two triangles, triangle A, B, C, and triangle D, E, F. Girls, it's very, very, very important here to name the triangles in a corresponding way. What do I mean by corresponding way? Can you see the two triangles? It's very obvious that A is the same as D, B is the same as E, C is the same as F. So when you name the two triangles, try to name the corresponding parts like each other. Yani A, B, C, D, E, F. Didn't we say that A is the same as D? B is the same as E, C is the same as F. This is corresponding means. So triangle A, B, C, and triangle D, E, F. Okay, place the two triangles next to each other as we did. Since the triangles are congruent, there must be a sequence of rigid motion that maps the two triangles together. Describe the sequence of rigid motion. Who can tell me how can I change triangle ABC into triangle DEF? What happened? It appeared to be, translation, right? It's moving, yeah, as if it moved right and then down. But actually points C and F are not quite straight, yani they are not parallel. I think there is a certain angle of rotation. You know, I think it rotated a little bit with a certain degree. It rotated a little bit with a certain degree and then it translated. So in question B, I'm going to tell him what is the sequence of my transformation. Did I say what is the page here, by the way? We didn't say the page. We are in page, just for you to consult, 909. Yes, page 909. Okay, so for question B in page 909, we are going to write page 909, question B. It's going to be rotation and translation. So I rotated a little bit and then I translated. Okay? Okay, let's go back to our book. The same sequence of rigid motion that maps triangle ABC maps each part. Yani when you do a rotation and translation, actually each part of the triangle is moving. Yani point A or angle A is rotating and then translating. Angle B is rotating and then translating. Angle C is rotating and then translating. The same thing is happening for the measures, يعني for the length, يعني for AC, for AB, and for BC. يعني in other words, since triangle ABC is congruent to triangle DEF, so each part in triangle ABC is congruent to each part in triangle DEF, which means I can write AB will map to DE. Look from here, it's mapping from here. That's why I'm telling you should write the triangles in a congruent way. But each time, girls, he will give you the triangle. You have to, when he asks you which is congruent to which, you have to find from the writing, from the name of the triangle. So here AB is facing DE. So I'm going to tell him AB is congruent or yani maps to DE. And let's see in the shape, AAB is the same as DE. So we are right. So BC is mapping to what? To EF. So let's see in here. BC is mapping to EF. So we are right. So we are going to write here BC maps to EF. What about AC? AC. Look, I'm jumping. AC. Here, DF. So let's see here. AC and DF. So we are right again. So AC maps to DF. What about angle A? Angle A maps to angle D. So you are going to write here D. Angle B maps to angle E. Angle C maps to angle F. Right? So AB was corresponding to DE. Yani AB is the same as DE in the other triangle. BC was corresponding to EF. AC was corresponding to DF. And the same thing is happening for the angles. So what I can say that when two triangles are congruent, so their corresponding parts are congruent. And when I tell you that these two triangles are congruent, يبقى the corresponding parts, the similar parts to each other are congruent as well. Yani I can say that AB is congruent to DE, BC is congruent to EF, AC is congruent to DF, angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. You understand? So this is what is the meaning of our headline of the lesson. Corresponding parts of congruent figures are congruent. So in question C, what does step C tell you about the corresponding parts of the two triangles? That they are what? That they are congruent. So this is what you are going to write. For question C, in here, corresponding parts are congruent. Okay, corresponding parts are congruent. Let's write part C. Corresponding parts are congruent. Okay, going back to our book. Sorry, this was question D, by the way. This was question D. The thing that we did now, it's not C, it was question D. This was not, this was D, okay? D, question C was the one in which we completed the corresponding parts equality. But here, just no, this is question D. Okay, so going back to the book, reflect 1. If you know that triangle ABC is, and this thingy, we said what is this? Means congruent. So if you know that triangle ABC is congruent to triangle DEF, what 6 congruent statements about segments and angles you can write? That's the thing that we wrote up here. Since I am talking about a triangle, in triangle we have how many sides? We have 3 sides. And how many angles? We have 3 angles. We are going to write that AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. Those are the sides. Let's talk about the 3 of the angles. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. And why? Because corresponding parts of congruent figures are congruent. So this is what you are going to write. You are going to write this exactly. Yes, this is what we wrote exactly. So AB is congruent to DE. Write this mark. Do not write congruent. No, from now on we are going to be using this mark. So AB is congruent to DE, BC is congruent to EF, AC is congruent to DF, and then the angles. And why? Because the rigid motion that map triangle also map the sides, which mean that corresponding sides and angles are, you can just write, by the way, instead of all of these sentences, instead of all this sentence, just write that corresponding parts of congruent figures are congruent. You don't need to write all of this. Just write corresponding parts of congruent figures are congruent. Okay? Okay. Going back to our book. We don't need to do reflect number 2. We're just going right away to our explanation. The first explain 1, corresponding parts of congruent figures are congruent. The following rule or statement summarize what you discovered. This is the rule, and the statement that we are going to read now is the whole lesson. If 2 figures are congruent, then the corresponding sides are congruent and corresponding angles are congruent. So using this, let's try to solve these 2 questions. I'm going to solve with you these 2 questions, and then you will have to do your turn by yourself. Example 1, given that triangle ABC is congruent to triangle DEF. Without seeing here, girls, you have to establish the congruence from here. Yani, do not ask yourself from the figure which is congruent what. Find the congruence from the name, as we did in reflect 1. Find the given side length or angle measure, and he is finding DE. From here, DE is congruent to what? AB, right? So let's go to AB. What is the value of AB? 2.6 centimeter, right? So DE is equal to 2.6 centimeter. Did you see what did we do? Just right away. From here, he was asking about DE. I went here. DE is corresponding to AB. So DE should be congruent to AB. Step 2, I went to my picture and saw AB is actually 2.6 centimeter. So DE is going to be 2.6 centimeter. As he did here, find the side length that corresponds to DE. But we said that AB is congruent to DE. Using the picture or using the figure, AB is 2.6, so DE is 2.6 centimeters. Let's do the same thing for measure angle B. From the name, angle B corresponds to angle E, right? So angle B is congruent to angle E, right? Let's go to the picture. Angle E is 65 degree. So angle B is 65 degree. So this is what we are going to write in here. Find the angle that corresponds to angle B. Since triangle ABC is congruent to triangle DF, so angle B is congruent to which one? Angle B is congruent to angle E. So you are going to write here E. Here we are going to write angle E. Find the unknown angle measure. Measure angle B equal measure angle E. And measure angle E equal 65 degree. So measure angle B is 65 degree. يبقى here we wrote E. Here we wrote E. E 65 and 65. Girls, there is a very, very important thing here that unfortunately may lose marks for you. When you are talking about a side length, you have to write for me the unit of the side. Yani it's a centimeter, it's an inch, it's a meter, it's whatever. You have to write the unit for you to and for me to understand that this is a side length. If you are talking about an angle, you have to write the degree for me. You have to write the degree for me. 65 degree. This circle, small circle here is called degree. And it's written up. So you have to write for me 65 degree, 73 degree, whatever degree. If it's a side length, you have to write centimeter. This is very, very, very important. Okay? Okay. I will leave your turn for you. You have to find number 4 and number 5. Okay, number 4 and 5. Okay, going to explain to applying the properties. We have here three properties. First of all, the first property that we have is called reflexive property of congruence. Reflexive means what? Just AB is congruent to AB. You are never going to use it. Just know the name. That this, when AB is equal to AB or AB is congruent to AB, this is called reflexive property. The second property, symmetric property of congruence. If AB is congruent to CD, then CD is congruent to AB. Like when I tell you if X equal Y, so Y equal X. Just you like flip the two numbers together, it will be true. It will be true statement, right? And when I tell you that X is equal to Y, so Y is equal to X, it is the same thing. This is called symmetric property. The third property, this property you are going to be using. This is important. Transitive property of congruence. Transitive property of congruence. What is this? If AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. What is this? Let me give you a smaller and an easier example. What if I tell you, for example, that A is equal to 2 and 2 is equal, or for example, better, A is equal to X and X is equal to 2. A is equal to X and X is equal to 2. So I can say that A is equal to 2. Right or not? I am telling you that A is equal to X and X is equal to 2. So I can write that A is equal to 2 right away. I already know, since A is equal to X and X is equal to 2, so actually A is equal to 2, right? This thing that we wrote here is called transitive property. This thing here is called transitive property. Is when you are using one variable or one thing as a transitive thing, as a transition between two things. Yani actually what is the important thing for me is that A is equal to 2, right? But to find A is equal to 2, I used a transitive thing, which is X. Since A was equal to X and X was equal to 2, so A was equal to 2. This is called transitive property. Okay, let's go back to our book and see how can we use the transitive property to find the missing things. Given that triangle ABC is congruent to triangle DEF, ABC is congruent to triangle DEF, find the given side length or angle. And he is finding AB. Let's find AB. In here, AB is congruent to what? To DE, right? AB is congruent to DE. So AB will be equal to DE. Let's go and see. I'm trying to find AB, right? We are trying to find AB. AB is what? Is 3x plus 8 inch. And it's equal to what? To DE, which is what? 5x. So we can write an equation here. That 3x plus 8, didn't we write that AB is equal to DE? AB is what? 3x plus 8. DE is what? 5x. So 3x plus 8 is equal to 5x. And then solve the equation to find what? Find x. How to solve it? Combine like terms together. I will flip 3x in the other side. Switch side. I will move 3x to the other side. So it's going to be 5x minus 3x. And 8 will remain as it is. 5x minus 3x is 2x. 8 equal to x. How can I get rid of 2? Divide by 2. Divide by 2. So x is equal to 4. We found x is equal to 4. Did we finish? Remember what was the question? To find AB. AB is 3x plus 8. So what should I do now? I should substitute x instead of x. So AB is 3 multiply 4 instead of the x plus 8. On your calculator, you will find the answer to be 20 inch. Did you see how did I wrote inch? Very important. So the answer was 20 inch. Let's do the same thing for measure angle D. In here, measure angle D is corresponding to A. So angle D is congruent to angle A. D is congruent to A. And 6y plus 2 is equal to 5y plus 11. Let's see in here. Since triangle ABC is congruent to triangle DF, so which is congruent to angle D? Angle A is congruent to angle D. Therefore, measure angle A, is equal to measure angle D. Then we are going to go to the figure. Angle A is what? 5y plus 11. So 5y plus 11 equal 6y plus 2. 5y plus 11 equal 6y plus 2. And then he is telling you here what to do. You are going to shift y together and the numbers together until you find the answer. Y will be equal to a certain number. Y will be equal to a certain number. You have to complete it by yourself. Very easy. Complete and find y. Y will be whatever. And then to find measure angle D, what should I do? I should substitute inside of D. D was 6y plus 2. So I should 6 multiply whatever number you find plus 2 equal whatever. And remember, you have to write for me the what? The degree, because this is an angle. So you have to finish this, please, and show me your answers. And you have to do question 6 and 7 as well. The same idea. The same idea. Nothing new. Okay? Okay. The last part in the lesson. Using congruent corresponding parts in a proof. Using congruent corresponding parts in a proof. Proof. Very, very, very important thing from now on. And this is the thing that we are going to be using for the whole module 19. What is a proof? A proof is when he gives you a certain statement or a certain rule or a certain theorem, and you are required to prove that this is true. You are not required to tell him if it's true or false. It's already true. But you have to use your knowledge and your understanding of angles and your understanding of congruence and these things to tell him why is it true. This is the proof. Okay? To do the proof, there is a certain way to do the proof of the geometry. This is the way. Each time he will tell you write a proof, you have to go draw for yourself a table. The table will be divided into 2 columns. The first column is called the statements. The second column is called the reasons. In the statement, you are telling him that whatever is congruent to whatever, measure angle whatever is equal to whatever. And in here, you are telling him the reason of each statement. Let's see what's happening here. Question A. First of all, he told me write each proof. I went and drew a triangle with 2 columns, statement and reasons. How many statements we are going to write, we will see. Given that triangle ABD is congruent to triangle ACD, each time he will give you a problem, he should start with the given. Yani something is given for you, and then what is required to prove. This is the beginning of your proof, the first thing that is going to be put inside your table, the given thing. The proof, it should be the last statement. And then in between, it is the transition thing. What did you do to prove? What did you do to go from the given thing until you find your proof? Okay, given here that triangle ABD is congruent to triangle ACD, they are congruent. Prove that D is the midpoint of BC. We need to prove that D is the midpoint of BC. First of all, let's understand. For D to be the midpoint of BC, it means what? D is exactly in the middle. It means that BD should be equal to DC, right? BD should be equal to DC. Equal means congruent. Yani I can use the congruent thing. So let's see. Using the triangle thing, using the congruent thing, BD is congruent to what? To CD. BD is, I want only CD, is congruent to CD, right? This is what we are trying to prove, that BD is congruent to CD. So since BD is congruent to CD, I can write that D is the midpoint, right? Right, like this, I already formulated a plan for myself. I understood that since these 2 triangles are congruent, so BD is equal to DC because they are congruent, because corresponding parts of congruent figures are congruent, so D is the midpoint, right? Let's write the proof. The first statement of the proof will always be the given. Whatever given he tells you, you should write it. Any givens he tells you, you should write it. So I wrote here triangle ABD is congruent to triangle ACD, statement 1. And why did I write this? Because this is given. So the first row in any proof will never change. Always you will find what is given, you will write it, and then you will write the reason is that because this is given. Okay? And then I discovered, since these 2 figures are congruent, we discovered that BD is congruent to CD, right? So this is statement 2. BD is congruent to CD. And why is this? Because corresponding parts of congruent figures are congruent, the name of our lesson. Since I found that BD is equal to CD, so I can say that D is already the midpoint of BC. And why is this? Because this is the definition of the midpoint. Now, the definition of the midpoint is what? We already took this in module 16. The midpoint is is a point that divides the 2 parts into 2 equal parts. That divide your length into 2 equal parts. 2 equal parts. Now, this is what we wrote. 2 congruent parts. Since they were congruent, so D was the midpoint because this is the definition of the midpoint. Okay, let's go to the second part in here. I will do with you question B as well. Given that quadrilateral JKLM is congruent to quadrilateral QR. This is one given. Take care that he gave you another given. Also, measure angle J is congruent to angle K. Measure angle J is congruent to angle K. And he is asking about to prove that angle J is congruent to angle P. As we said, the first thing I should write is our given. I have two givens, take care. Each one of them is going to be written in a statement alone. So first of all, quadrilateral is congruent, the first statement. Why? Because this is given. And then angle J is congruent to angle K. Why? Because this is given. Then let's try to use these givens to find our answer. Since these two triangles are congruent, he is asking about J and P. Angle J is congruent to what? To angle N. So this is not going to help me. According to the congruency, angle J is congruent to angle N. This is not going to help me. Let's go to the second angle. Angle K is congruent to angle P. The angle J is congruent to angle N. This is not going to help me. That's why I went to the second angle. Angle K is congruent to angle P. Angle K is congruent to angle P. But take care that he gave you a given in here. Angle J is already equal to angle K. You remember the example that we wrote here? A is equal to X. X is equal to 2. So A is equal to 2, right? Now let's write what we found in here. Angle J is congruent. I don't have the congruent mark in the keyboard, but you have to write congruent. So angle J is congruent to angle K, right? And according to the congruency, angle K is congruent to angle P. The same in here. Can you see? Can you see? Can you see? So I can write that angle J is congruent to angle P. Angle J is congruent to angle P. Required to prove. We already proved it. Using what? What is the name of this property? Transitive property of congruency. Did you see what did we write? So this is what you are going to do. So in here, this is how we finished our table in here. Yes. The first two statements is given and given. And since measure angle K is congruent to angle P, and why is this? Because they are corresponding parts. So corresponding parts of congruent figures are congruent. So angle J is congruent to angle P. Why? Using the transitive property of congruency. Okay. I know that the proof thing is a little bit hard because this is the first time for you to prove anything. This is the first time we take it. But don't worry, just try to practice on your turn example. Try to do it. And don't worry, for the whole module 19, we are going to be proving things. We are going to be using this table. Just practice, practice, practice. You will be able to write the statements and reasons in a very, very easy way. Don't worry. Just because this is the first time, it can be a little bit hard. But don't worry, we will practice a lot about this, so it will be, inshallah, easier for you. Don't worry. Okay, so what's required from you today is to do all of your turns, including number 8 and number 9. You have even number 8 and number 9. Try to do it, please. And inshallah, I will, in the beginning of tomorrow's video, will explain how to do it together in the first 10 minutes or so. Okay, thank you very, very much. Like this, module 18 is done and lesson 18 is done. Tomorrow, inshallah, we will be revising module 18. So try to just trap all of module 18 together. Thank you and see you tomorrow, inshallah.